All right, so in class today we talked about concavity and points of inflection, and one of the interesting sort of applications of concavity is how it sort of relates to tangent lines and how they interact with functions themselves. So I have drawn 4 graphs on my screen here, and they're pieces of graph, one of which is increasing and concave down. That's this first piece, where f prime is greater than 0, and the second derivative, which is concavity, is less than 0. One of which is decreasing and concave down, so my first derivative is less than 0, and my second derivative is less than 0. One of which is decreasing and concave up, so my first derivative is less than 0, and my second derivative is greater than 0. And one which is increasing and concave up, so my first derivative is greater than 0, and my second derivative is greater than 0. Now, what I'm going to do to each of these graphs is I'm just going to draw a tangent line to a point on that piece. And we're going to talk about the relationship of that tangent line to the graph. So here's the tangent line. Here's the tangent line. It doesn't have to be perfect, just sort of getting an idea of what they'll look like. Now, what we're going to be interested in looking at is whether the tangent line is above the graph or the tangent line is below the graph. Now, the tangent line falling above the graph happens on this graph and on this graph. And the tangent line below happens on this graph and on this graph. So if we look at the unifying traits of the tangent line being above, both of those graphs where the tangent line falls above are concave down, which makes sense because if the graph bends downward, then anything that's straight is going to end up going above that graph because the curvature will take it below something that's straight. And anything where the tangent line falls below, the graph is concave up. And again, that makes sense because the curvature would cause it to go up, and anything that's straight would be below that graph. So what this tells us is that if a function is concave down, meaning the second derivative is less than 0, then a tangent line is going to be above the graph. And if a function is concave up, meaning the second derivative is greater than 0, the tangent line is going to be below the graph. And this is something that we will use when we're answering questions on FRQs and on multiple choice questions on assessments. Now, for the purposes of this problem says, does the line tangent to the graph of f of x equals x times e to the negative x and x equals 1 lie above or below the graph of f and y? So this is literally asking us, is the tangent line above or below? It doesn't ask us to find the tangent line, it just wants to know if it's going to be above or below. So the way we find that out is we actually find the second derivative. So we find the first derivative first, it will be the product rule, first times the derivative of the second, which would require the chain rule, plus second times the derivative of the first. And I'm going to simplify that. And then I'm going to find the second derivative. And again, the product rule for that first part. First times the derivative of the second, plus second times the derivative of the first. And then plus the derivative of e to the negative x, which again requires the chain rule. I'm going to simplify that. And I think that's negative 2e to the negative x. And then they want to build a tangent line at x equals 1. So I need to know if the concavity at x equals 1 is going to be greater than 0 or less than 0. So I'm going to plug in 1. So that's going to give me 1 over e minus 2 over e, which is negative 1 over e. That number is going to be less than 0. That tells us that the graph is concave down. And if you think about it being concave down, a tangent line drawn there is going to be above. So the tangent line is going to be above the graph. And that's going to be because the second derivative at 1 is less than 0.